Welcome to qnawire.
So to use the first derivative test to figure out the local minimum and maximum values of our function f of x, the first thing we need to do is find our derivative. So f prime of x is equal to, using the power rule, 1/2 x to the negative 1/2 minus 1/4 x to the negative 3/4. And I found this just using the power rule, like I said. And now what we want to do is just set this equal to 0 and solve for x. So if we let 0 equal 1/2 x to the negative 1/2 minus 1/4 x to the negative 3/4, we can first add 1/4 x to the negative 3/4 over to the other side. So you get 1/4 x to the negative 3/4 is equal to 1/2 x to the negative 1/2. And now we can multiply both sides by x to the 3/4, and this will get rid of this x to the negative 3/4. So we can cancel these, and we can add the exponents on this side of our x's. So negative 1/2 plus 3/4 is 1/4. So we get 1/4 is equal to 1/2 x to the 1/4. And now we can multiply by 2. So we get 1/2 is equal to x to the 1/4. And now we're going to raise both sides to the 4th power. And we get x is equal to 1/2 to the 4th, which is 1/16. So our derivative is equal to 0 at x is equal to 1/16. So what we want to look at are values of x that are less than 1/16 and values of x that are greater than 1/16. And look at the sign of our derivative to figure out if this is a max or minimum value. So if we go back to our derivative again, and if we plug in a value of, let's just say, 1 over 100, x to the negative 1/2 of 1 over 100 would be 1 over 100 to the 1/2, which is 1 over 10, and then to the negative 1 would be 10. So we'd have 10 times 1/2, which is 5, minus 1/4, 1 over 100 to the negative 3/4. So I'm just going to plug this into a calculator real quick. And 1 over 100 to the 3 divided by 4 is equal to around 0.03. And then if we multiply that by 4, or sorry, we actually need to take this to the negative 1. So we need to do 1 divided by our answer, so 1 divided by answer, and then times 0.25. It's around 7.9. So we figured out 1/2 times 1 over 100 to the negative 1/2 was 5, and we're minusing 7, so that's going to give us a negative value for our derivative. So when x is less than 1 over 16, we have f prime of x being less than 0. And now we're just going to look at values of x that are greater than 1 over 16. So let's just choose x is equal to 1. So 1 to the negative 1/2 is just 1, so we get 1/2 minus 1/4 times 1 to the negative 3/4, which again, 1 to the negative 3/4 is just 1, so this is 1/2 minus 1/4, which is positive. So when x is greater than 1 over 16, our derivative f prime of x is greater than 0. And since we're going from negative to positive, or from a decreasing slope to increasing slope, that means that we have a local minimum at this x value. So at x is equal to 1/16 is a local minimum value. And now what we can do is just plug in 1/16 into our original equation. And if we do that, and you do the math and we calculate this, this is equal to negative 1 over 4. So our local minimum occurs at 1/16 comma negative 1 over 4. And now if we want to use the second derivative test, so second derivative test to find the local extrema instead, what we would do is find the second derivative of our function. So we know that f prime of x was equal to 1/2 x to the negative 1/2 minus 1/4 x to the negative 3/4. So we can use the power rule again to find the second derivative. So f double prime of x is equal to 1/2 times negative 1/2 is negative 1/4 x to the negative 3/2 minus 1/4 times negative 3/4 is negative 3/16. And then we also have this negative sign here, so this is positive 3/16 x to the negative 7/4. So now that we've found this derivative, and we know that our first derivative is equal to 0 at x is equal to 1/16, what we can do is plug in 1/16 into our second derivative. So f double prime of 1/16 is equal to negative 1/4 1/16 to the negative 3/2 plus 3/16 times 1/16 to the negative 7/4. And if you find this by plugging it into your calculator, this is going to be equal to 8, which is greater than 0. And whenever our second derivative is greater than 0 at a critical point, that means that that is a local minimum. So using the second derivative test, we found that this was a local minimum at the point 1/16, comma, negative 1/4. And in this case, I preferred using the first derivative test since the second derivative was a little harder to find since we had some weird numbers here. So I preferred using the first derivative test, but both work and both are great ways to figure out if you have a maximum or minimum value.